Hello, my name is Muhammad Aiman bin Amraman. My matrix number is 07DTP19F1018. And now I will talking about the 4.0, which is tool and die. So we go through to the topic, which is what is tool and die. Tool and die makers are highly skilled craft people working in the manufacturing industry. Variations on the name include tool maker, die maker, mold maker, or tool jig and die maker, depending on which area of concentration or industry an individual works in. Tool and die makers work primarily in tool room environments, sometimes literally in one room, but more often in environment with flexible semi-permeable boundaries from production work. They are skilled artisans or craftspeople who typically learn their trade through a combination of academic coursework and with substantial period of on-the-job training that is functionally an apprenticeship. They make jigs, fixtures, dies, molds, machine tools, cutting tools, gouges, and other tools used in manufacturing process. Next is the 4.1, discuss die cutting operation. So there are many die cutting operations. So for the first one is about the blanking. Blanking is the operation of cutting out flat areas to some desired shape. Blanking is usually the first step in series of operation. The metal punch out is the required product in blanking. Next, the piercing. Piercing is the operation of producing a number of evenly spaced holes in a regular pattern on the sheet metal. In piercing, the diameter of the punch point equal to or less than the thickness of the work material. And then the lancing. Lancing consists of cutting a sheet metal through a small length and then bending this cut portion. Then is the cut off. Is cutting along a line to produce blanks without generating any scrap in the cutting operation. Most of the part outline having been developed by notching or lancing in preceding stations. The cut-off line may have almost any shape, straight, broken, or curved. A cut-off die may be used to cut the entire outline of the blanks whose shape permits nesting in a layout that uses all of the material except possibly at the end of the strip. And then the parting. Parting is the separation of blank by cutting away a strip of material between them. Like cut off, it can be done after most of the part outline has been developed by notching or lancing. Some scrap is produced in making blanks by parting, which is therefore less efficient than cut off in the use of material. And then next is the notching. Notching is an operation in which the individual punch removes a piece of metal from the edge of the blank or strip. The reason for notching include the following, which is the number one is to free some metal for drawing and for forming, while the workpiece remains attached to the strip. Number two is to remove forming excess metal before. And number three is to cut part of the outline of a blank that would be difficult to cut otherwise. And then lastly is the shaving. Shaving is a secondary process that can be used to improve edges of cuts that have already been made. Shaving uses very little clearance to perform a straight, smooth, accurate cut to only at the end of the edge. And then we talk about the cutting action in punch and die operations. The punch contacts the workpiece material supported by the die and a pressure build-up occurs. When the elastic limit of the work material is exceeding, the material begins to flow plastically. The punch penetrates the work material and the blank is displaced into the die, opening a corresponding amount. A radius is formed on the top edge of the hole and the bottom edge of the blank. And then number 3 is the relation between die clearance with the cutting action in punch and die operation. How is clearance typically determined between the punch and die for die cutting operations? So the clearance between each side of the punch and the die is normally expressed as percentage of the material thickness. The clearance provided between the punch and die depends largely upon the mechanical properties of the metal to be shaped and the operation being performed. And next I will talk about the 4.2, which is types of die in manufacturing process. So this is the process dies that we found, which is the blanking dies, piercing dies, bending dies, forming dies, drawing dies, progressive dies, compound dies, and lastly is combination dies. For the blanking dies, blanking is a way of cutting flat material by trimming it from its exterior edge. The blanking die usually compresses uniformly, creating a precise degree of flatness. Next is the piercing dies. Piercing is a shearing process where a punch and die are used to create a hole in sheet metal or a plate. The process and machinery are usually the same as the used in blanking, except that the piece being punched out is scraped in the piercing process. And then the piercing dies. There are many specialized types of piercing, which is the lancing, perforating, notching, nibbling, shaving, cut-off, and dinking. The amount of clearance between a punch and die for piercing is governed by the thickness and strength of the workpiece material being pierced. The punch die clearance determines the load or pressure experienced at the cutting edge of the tool, commonly known as point pressure. Excessive point pressure can lead to accelerated wear and ultimately failure. Burr height is typically used as an index to measure tool wear because it is easy to measure during production. For simple piercing operations, pancake die is used. And then we talk about the bending dies. Bending is the process of deforming a base material through pressure from a die. For example, if the product requires an L bracket design, the die descends and curves the length of material into 90-degree angle. Next is the forming dies. This process bends the base material or blank along a curved surface and is often used in conjunction with drawing to fabricate rounded cylindrical parts. Next is the drawing dies. Drawing is a method of pulling material to a designated length, resulting in a thinner, longer workpiece. Products such as tubing, bars or wires are often fabricated through drawing. And then the progressive dies. A progressive or follow-on die has a series of operations. At each station, an operation is performed on a workpiece during a stroke of the press. Between strokes, the piece in the metal strip is transferred to the next station. A finished workpiece is made at each stroke of the press. While the piercing punch cuts a hole in the stroke, the blanking punch blanks out a portion of the metal in which a hole had been pierced at a previous station. Thus, after the first stroke, when only a hole will be punched, each stroke of the press produces a finished washer. And for the lastly is the combination dies. With the growing demands in the metal stamping industry, the workstations are required to produce more in less time to keep in synchronized. Combination dies are used in workstations to handle a combination of processes. In these dies, the cutting of the metal sheet is combined with other actions such as drawing or bending. So, as the name suggests, combination dies are designed to handle a combination of tasks or processes on the workstations. These are widely used across the globe, and here are some of the benefits that manufacturers are experiencing.
Hello, my name is Muhammad Sharif Ismail. My matrix number is 07-DTP19F1034. So I will present about complete the die designing. So for the first, we have the die block before the design is complete. After that, we have the punch and the punch plate, and then we have the pilot, stirpers, and pressure pad, and then we have the force mechanism involved in die operation, and then we have the blank size. The blank size is the alternate method for calculating the minimum blank size is to measure the frame while on the rear. The distance from the pupil center to the widest point of the rim of the frame. Then double provide the minimum blank size. Don't forget to add the extra 2 mm to allow for better and lens edge width. And then for the bending method, we have this diagram. And then the bending allowance and bending pressure. And then the percent reduction, draw and drawing force. And then after all of this, the design is complete. After this, I will explain about the perform 3D design of blanking dies. For the first, we have the design blanking part, and then we have a blanking dies of the blanking part, and we have a detailed drawing of the blanking dies, and then the assemble of the blanking dies, and for the last is an explode drawing of the blanking dies. And then that's all for me. Thank you.
Lastly, we talk about the 4.5, which is the sustainable elements. So we'll talk about these two, which is the number one is controlling the temperatures. The friction of chip removal generates heat during the cutting operation. This heat might wear down your tools over time. As a result, it's critical to keep as much of the generated heat under control as possible. A carbon coolant system can assist manage the amount of heat created during the cutting operation, reducing tool damage. And then number two, lastly, is the appropriate tool design. Decent design is one of the finest methods to assure that a tool will endure a long time. Cutting tools must accomplish high metal removal rates while putting the least amount of strain on the tool. These instruments must be able to withstand the strain of multiple simultaneous movements, and a tool that has been appropriately built will be able to withstand the stresses of the operation without being harmed. So that is about 4.0, and thank you.